This is Unit 6, Lesson 1, Families of Functions. Student Learning Target. This lesson will teach me to name the 7 function families and their equations, to sketch the parent graph of 7 function families, and describe the general characteristics of 7 function families. Define function family. Function family is a set of functions whose equation have a similar form. And the parent function is the equation with the simplest form. Here's an example. Y equals x squared is a parent function of y equals 2x squared plus 5x minus 2. Notice how complicated the second equation looks and how simple the first looks. The first is the simplest way that you could write anything with the exponent of 2. Quick reminder, when we deal with functions, we're dealing with graphs where every one input has exactly one output. And these are graphs that also pass the vertical line test. All of these things, because we're dealing with function families, they are all functions. These are some function families that you've worked with before, so I'm referring to them as the old function families. You have linear. On your notes, you have a couple of columns. So for the parent function is y equals x. That is the most simple linear function. The graph, go ahead and sketch your x, y, and axes. The graph of something with a parent function of y equals x is going to be simple here. Think about what we just finished. Has a y-intercept of, has a slope of 1 and a y-intercept of 0. It's in its most simple form. So a couple things to note. The y-intercept, you can write this under characteristics, is 0, 0. The slope is 1. And I guess in this case, the x and y-intercept are exactly the same. Absolute value. Actually, let me go back to linear. Linear, anything that makes a line. So here's the family name. Here's the equation, graph, characteristics. So family name, absolute value. Think about value, V. The parent equation is y equals the absolute value of x. It's as simple as it gets. In regards to its graph, it's going to make a V shape. Because it is simple, its V shape is going to start here at 0, 0, and both sides are going to increase. General characteristics, it's very similar to the line in that it has a y-intercept at 0, 0. It's made up of 2 lines. The slope of one of the lines is negative. And the slope of the other line is positive. So think about that one's going downhill, that one's going uphill. And when we talk about the y-intercept being at 0, 0, this point has a special name. It's referred to as the vertex. So I want you to know that the vertex is at 0, 0 as well. The line doesn't have a vertex because it's not a specific point. Lines are continuous. This is kind of like a turning point. You could think of the vertex. The next function, quadratic. These are our equations that have an exponent of u, exponent of 2, so they make a u, y equals x squared. These are going to give you that u shape. The u is centered here at 0, 0. And goes up from there. This is our first graph that is nonlinear. And it has a vertex at 0, 0. its y-intercept, its x-intercept. For this particular one are also at 0, 0. So here, the vertex is the vertex. It's that kind of important point where the graph is turning. It's the y-intercept, it's the x-intercept. It won't always be. These are just for parents. So here's your parent function. That needs to be in the parent category. Make sure you sketch your graph. And then these 3 bullet points are your general characteristics. Couple more. Square root. We've seen a little bit of square root. The equation for square root is y equals the square root of x. The shape is actually very similar to the shape of the square root itself. It starts at 0, 0, and it curves and then kind of flattens out. So it's increasing slightly and then increasing even more slowly. So some characteristics. It begins at 0, 0. And I'm not going to call it the vertex because it's not a turning point. It's literally its first point that works. The reason why it begins at 0, 0 is because you can't have a negative value. Or you can't have a negative under the square root. So if you were to try to make any other value, the square root of -2, your calculator won't do it. The square root of -1, calculator won't do it. Square root of 0 is 0, so it's the very first value that actually ends up working. What else can we say about it? It increases and flattens out. You can write that down. It increases and then kind of flattens. Think about it as kind of a U on its side if you want to, but it doesn't have the bottom. And we will explain in class what we mean by it being a U on its side but without the bottom. Cubic. The parent function of a cubic is y equals x to the third. Think about cube, cubic, and its function has a major turning point at 0, 0. It has a point here at 1, 1, and has a point here at -1, -1. And what it's actually going to do is it's going to come in, not straight down, but curved. It's going to curve, curve again, and then it's going to keep going. So it's not shooting straight down as much as it's gradually turning. This is a function, so it will pass the vertical line test. It just looks nearly linear, but it really isn't. So this one has 3, I'm going to call them nice points. It has that center turn at 0, 0. And then what this shape is it's kind of taken from the U. Think about y equals x to the second for a second. We said on the previous page that it was a U shape. Think about it. If we take -2 and square it, you get 4. -1 and square it, you get 1. So what happens when you go to graph is all of these negative values, a -2 squared is up here, a -1 squared is up here, -2 squared is up here, 3 is up here, 4 is up here, because when you take a negative times itself, it's always going to give you a positive. But if you try it with a cube root, -2 to the third power, even with parentheses, you end up getting a -8. So a negative times a negative times a negative ends up being way down here. A -1 to the third power is still a -1, so it ends up snapping down. When you goofed up these square problems at the beginning of the year, a lot of you would forget the parentheses. And so you were incorrectly writing this. And it was taking a negative times a positive, and it was graphing your U shape. Positive was always fine, but the negative side was always wrong. So you were actually graphing a cubic when you should have been graphing a quadratic, which is that x to the second. So cubic has 3 nice points, centered at 0, 0, and it does kind of give you this kind of wiggle turn type shape. Cube root, just like square root, where we had this check mark symbol, the cube root does it, but it's in regards to cubic. So think about taking y equals x to the third and square rooting it. It's essentially what it's going to look like. Let me rewrite this equation a little nicer for you. We end up putting the 3 on the outside because it's a cube root. Think about this symbol as meaning root. The way it looks is it starts here at 0, 0, and it has a nice point here at 1, 1, and it also has a pretty point down here, just like it did for cubic. The difference, though, is that it's the cubic shape turned on its side, just like this square root. Picture this. This square root is really a U turned on its side, but without the bottom. And the bottom's there because you can't have the negative values. So just like the cube root, we're going to take this cube root shape and we're going to turn it a little bit. And it ends up looking like this. It's flat, kind of curved, just like the square root, but this one has another half. And this half down here is allowed to be there because you are able to have a negative value inside the cube root. So some main points to draw or to write. This is a cubic, turned sideways. So it's a cubic turned on its side, and this one has a bottom. Where that one, where'd it go? Did not. Last one, rational. The word ratio is really the word fraction. So this function is going to be a fraction. Y equals 1 over x. Notice the x is on the bottom. It's a two-part fraction. It's kind of funny. It is a curve in the first quadrant, and it's also a curve in the third quadrant. And when you graph it, a lot of graphs are going to give you these dotted lines. So let me give you a couple of main characteristics. This one has 2 pieces because you can't have 0 in the bottom of a fraction. So if you were to put 1 over 0, it doesn't exist, which is why it's not a solid line. Where I drew those green lines, it doesn't actually exist. So it's going to graph the first piece. You can't graph anything here at 0. It doesn't exist, so it completely skips it, and then it goes on to graphing in the negative side. So it can do 1, it can do 2, it can do 3, all the way out to infinity. It can do -1, -2, all the way out to infinity. Almost out of time, so a couple more here. It won't ever touch the x or the y-axis. And that is referred to as an asymptote. So this is where we're going to have to leave off. The rest of the notes will be finished in class. Please make sure that you have all of your notes filled out the best you can. I know that there's been a lot of crazy writing. Come to class with questions so that we can begin discussing our function families.